Hello guys, welcome to our channel Row and Basic. So in this video we will learn how to solve for logarithmic inequalities. Okay, so let us start. So before we start solving your logarithmic inequalities, let us define some properties that we should use. So if b is greater than 0 but less than 1, then x sub 1 is less than x sub 2 if and only if log of x sub 1 base b is greater than log of x sub 2 base b. So in this property, your first property, so notice the bases, and on this condition the bases are between 0 and 1. So assuming this is your number line, so this is 0, this is negative 1. The condition is in between 0 and 1. So we have here fractions. Fractions less than 1 but greater than 0. And notice the symbol. So the exponents or the log x sub 1 and x sub 2. So here we have greater than, and this one is less than. So to be basic, when we are dealing with fractional bases on our logarithm, so we will reverse the symbol, your inequality symbol, when we are solving your log. Okay? Then number 2, or the second property, we have if b is greater than 1, then x sub 1 is less than x sub 2 if and only if log of x sub 1 base b is less than 2 log of x sub 2 base b. So the same with property number 1, we have here your bases. So if you can notice, b is greater than 1, so this is 1. So we are now dealing with numbers that are greater than 1. So I know you're familiar with numbers greater than 1. So in this case, most probably we will be dealing with whole numbers greater than 1, and the symbol is retained. So just like your exponential functions and inequalities, solving your exponential inequalities, we are following the reverse and retain of your inequality symbol. Okay, so I guess that you are now acquainted with these properties. So let us use these properties to solve for your solution sets. Okay, so on the board we have our first example. So for x, when our given is log of x base 3 is greater than 3. Okay, so copying the given logarithm, we have log of x base 3 is greater than 3. Okay, so in dealing with this kind of inequality, okay, so x must be retained on the opening of your inequality symbol. Then we will rewrite this logarithm into exponential form. So we have your base 3. From here, the base is 3. Then the logarithm is your exponent. So the exponent 3 in here is 1. Okay? So we are writing it into exponential form. Okay? Next is to simplify. So basic, x is greater than 3 cubed, and that is 27. Okay? So when x is greater than 27, so the values possibly are x greater than 28, 29, and so on. Okay, writing it using your interval notation, we have your parentheses from x, okay, from 27 until positive infinity. Okay, assuming we have your number line in here, then we have 0, -1, -2, -3, and so on. Assuming this is your positive 27, then we have numbers here until positive infinity. So we have there a null or open circle for number 27. Then we have this graph, a line graph that denotes your solution set from 27 until positive infinity, where 27 will not be included, okay, because of this one. Okay, so I guess that you can understand it using this illustration, or if you can write it using your set builder notation. X is an element of real number such that x is greater than 27. Okay, now let us check some values such as 28 and 29, or shall we say numbers greater than 27. So let's check 28. So let us use x equal to 28. Now let us substitute it in our original equation. So we have log of x, which is equal to 28 base 3 okay, then we have 3. So writing it using your exponential form, we have 28 is greater than 3 cubed. So we have 27 is greater than, 28 is greater than 27, of course. So true or false, of course, x equal to 28 will satisfy your inequality, as x is equal to 28, that is greater than 27. So therefore, we can say that x is greater than 27 are the solution set of your logarithmic inequality. Now let us proceed to our second example. Okay, so let us proceed to our next example. We have log of the quantity of 2x minus 5 base 1/2 is greater than log of the quantity of x minus 2 base 1/2. So if you can remember your first example, we have log of x base 3 is greater than 3. Okay? So in here, we are dealing with the base that are whole number, and on here, we will be dealing with the base or bases that are fraction. So if you can remember, the inequality symbol was retained. Okay? So let us proceed to this example. First, let us be sure that the logarithm of this number is greater than 0, or the logarithm of this quantity, or shall we say that we should be sure that this quantity is greater than 0, or this quantity should not be a negative quantity, because if this is a negative value, then this logarithm will not be defined, okay, or it will be undefined. So let us first check if 2x minus 5 is greater than 0. Simplifying, we have 2x is greater than 5. Okay? So minus 5 to the other side is positive 5. Then dividing both sides by 2. Now we have x is greater than 5 over 2. So 5 over 2 in decimal is 2.5. Okay? So remember these values. On the other side, we have x minus 2. Should be greater than 0. So x is greater than 2. Okay, so let us remember these values. 5 over 2 and 2. 5 over 2 or 2.5. Now let us solve for the logarithm of the second example. So we have log of 2x minus 5 base 1/2 is greater than log of the quantity of x minus 2 base 1/2. Okay, if you can see, our bases are fractions. So we have fraction 1/2 and 1/2. So it means that your symbol, your inequality symbol will be reversed. Okay? Again, when we are dealing with the bases that are fractions, the inequality symbol will be reversed. Okay? So if you can identify our bases are the same, using your 1-to-1 property, the bases are disregarded and we will solve for 2x minus 5 and x minus 2. So we used 1-to-1 property. Okay? Now let us isolate x on the other side. So we have 2x minus x and negative 2 plus 5. So how did we get these things? So to eliminate x on the other side, minus x. So minus x. Okay, so x will be eliminated on the other side. Then eliminate minus 5 in here. So we have plus 5. So therefore plus 5. Okay, so we have eliminated minus 5 in here. So the remaining is 2x minus x. Then we have minus 2 plus 5. Okay? Simplifying, we have 2x minus x is less than negative 2 plus 5 is x is less than 3. Okay, so checking these values on a number line for us to be sure. So example, here we have 0, negative 1, negative 2, and so on. So we have here 1, 2, and 3, and so on. So we have here values of 2. Then we have, let us expand this to emphasize. Assuming we have 3, so we have 3, x is greater than 2, x is greater than 2.5, so assuming we have 2.5 in here, 2.5 is in between, halfway between 2 and 3, of course. So we will be identifying your values that belongs to your solution sets. So example, the values that are greater than x, greater than 2, assuming we have 2.1, okay, 2.1. So let us check 2.1, and on here we will be checking 2.6, values that are greater than 2.5. Okay? So checking. So your first value is x equal to 2.1. So using your log, so our base is 1/2. So we have 2, and here we have 2x minus 5. So 2 times 2.1 minus 5 is greater than log. So our base is 1/2 again. X is 2.1 minus 2. Then computing this one, we have log. This is 2 times 2.1 is 4.2 minus 5 is greater than log. Then we have 1/2. Then we have this thing, 2.1 minus 2, of course that is 0.1. Subtracting 4.2 by 5, we get negative 0.8 is greater than log of 1/2, log of 0.1 base 1/2. So on here you can see that this number is negative. So the logarithm of a negative number is not defined. So we can say that this logarithmic inequality here is undefined. So the values that are greater than 2 here is undefined. So let us check 2.5. Okay, checking 2.5. So we have log. Okay, so I will erase this thing. Checking for 2.5 or 2.6 I mean. So let us use x equals to 2.6. Substituting, we have log of 2 times 2.6 minus 5. Quantity base 1/2 is greater than log. X is 2.6 minus 2. Quantity base 1/2. Then we have 2 times 2.6 is this one. We have 5.2 minus 5 is greater than log. 2.6 minus 2, of course, that is 0.6 base 1/2. Okay? Continuing, we have 5.2 minus 5, of course, it is 0.2. So we have log base 1/2. Then we have log of 0.6 base 1/2. So if you can see, we are dealing with fractions. So therefore, will be the inequality symbol will be reversed, and we have 0.2 is less than 0.6. Because the logarithms will be disregarded and we have to solve for 0.2. Reverse is less than 0.6. So this is correct. Okay? So we can be sure between x is greater than 2 and x is greater than 2.5 where should be our interval will be bounded. So we can say that our interval will be bounded from 2.5 to 3. Therefore, our solution set is from 5/2 or 2.5 until positive 3. Okay? Okay? Or shall we say that x is this one less than 3 but greater than x is less than 3 but greater than 5/2. Okay? So in your number line, the values of x that can satisfy your logarithmic inequality is between 2.5 and 3, where 2.5 and 3 are disregarded. Okay? Now let's proceed to another set of example. I hope that you understand these things. Okay, so for our next set of examples, we have on the board log of 3x minus 1 base 2 and log of the quantity of 3x minus 1 base 2 is greater than or equal to 3. So if you can notice, the values of our given logarithmic inequalities are the same. So what's next? Same or this one we have 3x minus 1, and here we have 3x or quantity of 3x minus 1. So let's check the difference of the two given, solving for its solution set. Okay? So first, let us be sure that the logarithm of this number is greater than 0. So we have this thing. To simplify this one, it is just like the log of 3x base 2 minus 1. Okay, so minus 1 is a constant subtracted from the log of 3x minus 2. And here, the log of 3x minus 1 as a whole quantity base 2. Okay, so guess you can identify the difference, the two. Okay, so solving, we have log of 3x is greater than or equal to 3 plus 1. So where did we get this plus 1? So we have added 1 here. So we will add 1 in here to eliminate this negative 1. So we have the remaining of 3x base 2. Then we have 3 plus 1 on the other side. So now we have 3 plus 1, of course, is 4. Then we have log of 3x base 2. Okay? Computing, we have 3x is equal to 4. Sorry. So our base is 2. Exponent is 4. This is writing your logarithm into exponential form. On here we have used your addition property of inequality. Then simplifying, we have 3x equals to 2 raised to 4 is, of course, 16. Dividing both sides by 3, isolating x. Now we have x is greater than 16 over 3. Okay? 16 over 3. Or x is greater than 16 divided by 3 is 5 1/3. Okay, so checking. So give me a number greater than 16 over 3 or 5 1/3. So I will use 5. Okay, I will use 16 over 3 to be exact, because sorry, our symbol is greater than or equal, so to be exact on this value, because we have here equal symbol, we will use 16 over 3 to check. Okay, so copying your log, we have log base 2 3 3x minus 1 is greater than or equal to 3. Substituting 16 over 3. So we have 16 over 3 minus 1 is greater than or equal to 3. Simplifying, we have 3 divided by 3 is 1 times 16, that is 16 minus 1 is greater than or equal to 3. Now we have log of 16 minus 1. Minus 1 is, okay, so we have log, so I have said earlier that this log of base 2 3x minus 1 is just like this one. Okay, so here they are the same. So this thing, we have log of 16 minus 1. 16 can be written as 2 raised to 4, that is 16 minus 1 is greater than or equal to 3. Then we have log of 2 raised to 4 base 2 is minus 1 is greater than or equal to 3. So disregard, the value of this one is 4 minus 1 is greater than or equal to 3. Then 4 minus 1 is 3 is greater than or equal to 3. Okay, so we can say that our solution set is from 16 over 3 until, because it is greater than, until positive infinity. We will be using this symbol, the bracket. We will use the bracket to denote that 16 over 3 is a part of your solution until positive infinity. In a number line, we can illustrate this as, assuming your 16 over 3 is here, as 16 over 3 is close to 5 1/3. It should be a solid circle, denoting that it is part of your solution set. So from 5 1/3 until positive infinity. Okay, so I guess that we are clear on that example. Let us proceed to this example and see whether they have the same solution or not. So we have log of the quantity of 3x minus 1 base 2. Now let us first be sure that the quantity 3x minus 1 is greater than 0. So we have this one. So 3x, 0 plus 1 is 1. X is greater than 1/3. So we can say that 1/3 is greater than 0. Okay, solving, we have, following your inequality symbol. So let's write 3x minus 1 here. Then your base is 2 raised to 3. Okay, continuing, we have 3x minus 1 is greater than or equal to 2 cubed is 9. Sorry, not 9. 2 cubed is 2 times 2 times 2, which is 8. Continuing, we have 8 plus 1. Then we have 3x in here. So plus 1 in here, plus 1 in here. So because we added 1 on the other side, we should add 1 on the other side too. So eliminate. Then we have plus 1. So we have now 3x greater than or equal to 8 plus 1. So we have now 9. Then on the other side, we have 3x. Dividing both sides by 3, we have x is greater than or equal to 3. Okay, so if you can see, our solution set starts from 16 over 3. On here, on this thing we have, it starts from positive 3. So we can say that our solution is from positive 3 until positive infinity. Okay? So if you have time, you can check it on your own using your calculator. So I just am making you see the difference between this logarithm and this logarithm. So I hope that you have learned something from this video. Please subscribe and stay safe.